Beneath the calm tropical waters of southern Japan lies a fracture that never sleeps. The Ryukyu Trench is a place where Earth is actively being torn apart and rebuilt in slow motion, where one tectonic plate is sinking into the mantle, dragging entire sections of the ocean floor down with it. For decades, it has remained largely overlooked, overshadowed by more infamous seismic zones. But the forces here are just as real and just as dangerous. Pressure is constantly building beneath the seafloor, locked between massive plates that refuse to move until they suddenly do. When that happens, the consequences can be immediate and devastating. Powerful earthquakes, fast-moving tsunamis, and volcanic eruptions fueled from deep below. Stretching like a broken spine across the sea, the Ryukyu Islands owe their very existence to the trench. From Kyushu in the north down toward Taiwan, these islands form what geologists call an island arc, a curved chain created by subduction-driven volcanism. Each island is, in essence, a surface expression of processes occurring far below. Magma generated deep within the earth rises upward, eventually breaking through the crust to form volcanoes. Over thousands to millions of years, repeated eruptions build landmasses that emerge above sea level. What appears today as a tropical island paradise is actually the top of a vast geological system rooted in heat, pressure, and motion. The Ryukyu Arc is not a static formation. It is constantly evolving, shaped by eruptions, earthquakes, and the slow but relentless movement of tectonic plates. Even the calmest stretches of coastline sit atop a dynamic foundation that continues to shift beneath them. At the heart of the Ryukyu Trench lies a powerful geological engine. The Philippine Sea Plate is moving northwest, gradually being forced beneath the Eurasian Plate. This process, known as subduction, is one of the most fundamental mechanisms shaping Earth's surface. As the oceanic plate descends, it carries with it sediments, water, and minerals from the ocean floor. With increasing depth, temperatures and pressures rise dramatically. Water released from the descending plate lowers the melting point of the surrounding mantle, generating magma. That magma then begins its slow ascent toward the surface, feeding volcanoes along the island arc. But subduction is not smooth. The plates do not slide past each other like perfectly lubricated surfaces. Instead, they lock together, grinding and resisting movement. Over time, stress accumulates. When it finally exceeds the strength of the rocks holding the plates in place, the result is a sudden and violent release of energy, an earthquake. This cycle of locking and release defines the Ryukyu Trench. It is a system driven by friction, pressure, and the slow inevitability of motion. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The trench itself is a world few will ever see. Descending more than 7,500 meters into the Earth's crust, it is a place of extreme pressure and total darkness. The walls of the trench slope steeply downward, forming a vast underwater canyon that cuts through the seafloor. At these depths, the pressure is crushing, hundreds of times greater than at the surface. Temperatures hover just above freezing, and sunlight never penetrates. Yet even here, life persists, adapted to conditions that would be lethal elsewhere. Strange organisms cling to the slopes, feeding on nutrients that drift down from above or emerge from hydrothermal vents. But beyond its biological curiosity, the trench is significant for what it represents, the boundary where Earth's crust is being recycled. The seafloor here is not permanent. It is being pulled downward, eventually to be melted and reformed within the planet's interior. The Ryukyu Trench fuels a chain of volcanoes that stretch along the island arc, some of which have produced enormous eruptions in the past. Some of the most active and well-known volcanoes in this region lie near Kyushu, where systems like Sakurajima erupt frequently, sending ash plumes high into the atmosphere and reminding nearby populations of the constant activity below. But much of the Ryukyu Arc's volcanism is hidden beneath the ocean. Submarine volcanoes dot the seafloor, many of them poorly studied and capable of erupting without warning, occasionally producing steam explosions or discolored water visible at the surface. One of the most significant volcanic systems in the arc is Kikai caldera, a massive underwater caldera. Thousands of years ago, Kikai unleashed a massive eruption that reshaped the surrounding region, sending ash across vast distances and triggering widespread environmental impacts. Events like this are rare, but they are reminders of the scale of energy stored within subduction-driven volcanic systems. What makes the Ryukyu arc particularly complex is the interaction between subduction and back arc extension. As the crust behind the arc stretches, it can create pathways for magma to rise more easily, fueling both explosive eruptions and quieter, continuous activity. Together, these volcanoes form a dynamic and evolving system, one that is constantly reshaping the landscape, both above and below the ocean surface. The Ryukyu Trench is not silent. It is constantly shifting, producing earthquakes both small and large. Most go unnoticed, detectable only by instruments, but they are reminders of the stress accumulating along the plate boundary. Unlike some other subduction zones, the Ryukyu system is complex. Parts of it may slip more frequently, releasing energy in smaller events. Other sections may remain locked for longer periods, allowing stress to build to much higher levels. These locked segments are the most dangerous, capable of producing powerful earthquakes when they finally rupture. While the trench has not produced a disaster on the scale of the 2011 Tohoku earthquake and tsunami, the underlying mechanics are similar. The same process of stress accumulation and sudden release applies here. The difference is not in the physics, but in the timing. At any moment, a section of the trench could fail, sending shockwaves through the earth and displacing the seafloor above it. When the seafloor shifts suddenly during an earthquake, it can displace massive volumes of water. This is how tsunamis are born. In the open ocean, these waves may pass unnoticed, traveling at speeds comparable to jetliners. But as they approach shallow coastal waters, they slow down and grow in height, transforming into walls of water capable of devastating entire shorelines. The islands along the Ryukyu arc are particularly vulnerable. Their proximity to the trench means that warning times could be extremely short. A tsunami generated here might reach nearby coastlines within minutes, leaving little time for evacuation. Historical records suggest that tsunamis have struck this region in the past, though not always with the same global attention as those affecting other parts of Japan. The risk remains ever present, tied directly to the behavior of the trench itself. Despite its significance, the Ryukyu Trench does not receive the same level of attention as other major subduction zones. Part of this is due to geography. Much of the system lies underwater, far from densely populated mainland areas. When events do occur, their impacts may be more localized or less widely reported. Another factor is timing. Without a recent catastrophic event to draw global attention, the trench remains in the background of public awareness. Yet this does not reduce its potential. Geological systems do not operate on human timescales. A quiet century can be followed by a moment of extreme activity. For scientists, the Ryukyu Trench is a critical area of study. Understanding its behavior is essential not only for regional hazard assessment, but also for broader insights into how subduction zones function. The future of the Ryukyu Trench is not defined by if major events will occur, but when. The Philippine Sea Plate continues to descend beneath the Eurasian Plate, steadily building stress along the plate boundary. Over time, this accumulated pressure will be released through earthquakes, some of which could be large enough to generate tsunamis affecting the Ryukyu Islands and surrounding coastlines. Advances in monitoring are improving our understanding of the region. Seafloor sensors, GPS networks, and ocean bottom seismometers are helping scientists track subtle movements and detect early signs of strain accumulation. Yet, despite these tools, predicting the exact timing of major earthquakes or volcanic eruptions remains extremely difficult. There is also growing interest in the arc's submarine volcanoes, many of which remain poorly mapped. As technology improves, previously hidden systems may be revealed, potentially reshaping how scientists assess volcanic risk in the region. Ultimately, the Ryukyu system will remain active for millions of years. It is a long-term engine of geological change, one that will continue to shape the landscape, influence hazards, and remind us that even the quietest oceans can conceal immense and unpredictable power.